go the lateral control. Lateral control. So lateral control mein aileron is providing you the control, right? You can draw some kind of wing here. For example, let's say I am drawing, and this is the aileron. Okay. Now I am positioning this aileron. This I am positioning as a y2. This I am positioning as a y1. Okay. Okay. And you draw in. Okay. You take some elemental strip which is have width of dy and chord C. Okay. And what is the position? Y of that elemental strip. Okay. So now, when you roll the airplane, for example, what will change? Rolling moment. Let's say additional rolling moment you are getting. This comes from the change in lift into this distance y, right? As simple. Okay. Now you can write half rho v square s into b del CL, and this you can write half rho v square s. What is the area? Area is C into dy. C is a chord, this portion, and dy into C into dy, and section lift coefficient I will call as a CL dash, and then this distance y. Okay. Now you rearrange delta CL. This half rho square will get cancelled. You will have CL dash. Okay. And CY dy divided by S into B. Okay. As simple. Do not confuse with lift coefficient, section lift coefficient, and what I have written here. Small l denotes the rolling moment, capital L denotes the lift, and dash I am denoting the lift coefficient at a section. What section? This aileron section. Okay. Now, section lift coefficient, how you can write? You can write CL alpha of the, let's say, wing. Okay. And then tau, and then delta A. What is tau? Tau you will write dou delta alpha by dou delta A. Like longitudinal case we have done, right? So plug this CL dash expression in that case. In that expression, what you will get? Delta CL equal to CL alpha tau delta alpha S into B. Okay. And here CY dy. Okay. Now if you differentiate, what you will get? CL delta A, and if you integrate, and this is a one side wing, so if you consider both the side, you have to multiply by 2, to 2 CL alpha of the wing tau divided by S into B, integral from y1 to y2 cy dy. From y1 to y1 you are integrating, right, and you are taking a small elemental strip dy. Okay. 2 CL alpha of the wing tau SB integral y1 to y2, and depending upon your position of the aileron, you will be having y1 and y2 limit, and if you integrate, you will get the what the control power is you are getting. So if I put the aileron towards the root, what will be the value of CL delta A? What will be the y near the root? Hi. What will be the? Very close to the root, roughly. Y1, right? It is small or large? Small, right? So that means this CL delta will be close to value. Value will be close to. See, if you have one force, large force, for example, but you have a very less distance. So what will be the moment? Near to 0, right? So that is why aileron is placed towards the tip, not towards the root. हमेशा आपने देखा होगा कि aileron जो है आउटर साइड में प्लेस होता है, ना कि इनर साइड में, ताकि आपको रोल मोमेंट मिले. कहां से? यहां से. CL delta S. Okay. So this is CL delta A. Okay. So this is all about lateral stability and control. Okay. Thank you so much.